All right, we're back here with part 2 now of Learning Guide 16. So we are going to look now at example 3. So in this situation, we have 4 sine squared x equals 1, and we're in radians. And again, exact solutions. So as soon as you see that exact solutions, please draw your exact triangles or your special triangles. So we have 1 root 2, and we have, that's the pi over 4, and the pi over 6, and the pi over 3 is this guy. Okay, so always keep that in your back of your mind because you're always going to be using these guys, okay? This guy. So now, what do we have here? Well, we always have to isolate. The examples I gave you in the last part, they were nicely isolated. So here, I have to get sine x by itself. So we're going to have to do some algebra. So I have 4 sine squared x equals 1. Well, the first thing I'm going to do is I'm going to divide 4 out. So that's gone. So now I have sine squared x equals 1/4. Now I want to get rid of the square. So square root, square root, square root. And now I've achieved my goal. This guy equals sine x equals plus or minus, because you're taking the square root of 1/2. So once you have it isolated, see sine x is nicely isolated, I can now go and do my steps. Okay, so let's look at where sine is positive and negative. So that is all quadrants. So we are going to have triangles in every single quadrant. And now we're going to label just like we did before. Remember, sine is O over H. So 2, 1, and I know that's root 3. This picture now tells me my reference angle, because that's our next step. Remember, the reference angle is the same there and there. It's all the same. So I know opposite 1 right here is going to be pi over 6. So this will be pi over 6. This will be pi over 6. This will be pi over 6. Now the last step is we have to find theta. Well, because we're in 4 quadrants, we know the first quadrant, I'll put over here, quadrant 1, the answer is pi over 6. Quadrant 2 now is going to be pi, take away pi over 6. Change that to 6, that to 6. So it's 5 pi over 6. In quadrant 3, we're going to go pi plus pi over 6. Remember 6, 6. That's 7 pi over 6. And then in quadrant 4, we're doing 2 pi take away pi over 6. And we make that 6 and that 12. So that is 11 pi over 6. So now those are our answers. So we can tie it up into, say, pi over 6, comma, 5 pi over 6, comma, 7 pi over 6, comma, 11 pi over 6. And there's our answer. Okay, so let's look at example 4. So again, it's going to be some little bit of algebra because we have to get the sine x to itself. And I know it's a quadratic because I have a square and I have an x here. So I have an x squared and an x. So I know it's a quadratic equation. And you can abbreviate to do your factoring. So I'm going to go 2s squared minus 5s minus 3 equals 0. Now, I know this is triple play or decomposition because of that 2 there. So 2s all over 2 multiply to get negative 6. And I know it's going to be 1 and 6. And I know it's going to be negative and positive. Now I have to get rid of this guy, so I know it goes into those two. So I have over here 2 sine plus 1 equals 0. And right here, because 2 goes in 2 once, it's sine minus 3 equals 0. Now, I have to isolate. So if I isolate the first one, let's isolate this guy right here. So I'm going to rewrite this over here. So I have sine x minus 3 equals 0. Move that over. Sine x equals 3. Now you should hopefully see that this is a problem, because if I write 3 as a fraction, it's over 1, correct? And remembering the ratio, we have O over H. Now, you got to be cautious. Sometimes you just reject and you do not solve situations. And this is a case, because in trigonometry, my hypotenuse is the longest side. And right now it's 1. It's a 1 and this is a 3. So this you would just stop. You wouldn't do it. Now let's look at the other one. So this guy here, I'll do over here. So I have 2 sine x plus 1 equals 0. So move over. So 2 sine x equals negative 1. Divide by 2. Divide by 2. So sine x equals negative 1/2. Now I can draw my triangle. So I know I have a sign that is negative. So we know it's in the bottom two. Label. So this is the hypotenuse, this is the opposite. And we remember that opposite 1, that's going to be pi over 6. See, I'm in radian, so make sure you read at the beginning. So now in quadrant 3, I remember it's going to be pi plus pi over 6. So I'll make that 6. So it's 7 pi over 6. And in quadrant 4, it's going to be 2 pi subtract pi over 6. And that is 11 pi over 6. So I have solved. Now this wants me to go one step further, right, in general solution. So just go plus 2 pi n NEI. All right, let's look at example 5 now. Well, example 5, if you look at this, I have a cos and a cos. Well, we can factor. A lot of times it's just going to be straightforward factoring to do our isolating of the trig function. So I'm just going to abbreviate this so we can see it clearly. I know there's a c common, so c comes out. And so now I know there's a cos x. Anytime you have something out, equals 0. And take the opposite of that guy. Cos x equals 1. Now we're running into a situation that we have a unit circle. Most of the examples, I think all of the examples prior to this, were ones that or the special triangles. So let's draw our unit circle. All right. So remembering back, we have 100, negative 100, O1 undefined, O negative 1 undefined, and it's always alphabetical. CST, 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 CST. Okay, so we can solve now. So in this situation, cos 0. Where is cos 0? Well, cos 0 is at the top and at the bottom. So I know the answer for cos 0 to be pi over 2, comma, and 3 pi over 2. All right, now let's look at this guy. Let's draw this unit circle. Where is cos 1? Right here, just right there. So I know that to be 0. Because up here, if you read carefully, you're including 0, not including 2 pi. So really pay attention. Now the general solution, we know that by now. Add the 2 pi n and the n e I. All right.